Okay. Okay, so when it comes to numerosity reduction, we have two types. One is what is called the parametric method. What happened to the PPT? Okay. Well, just a second, our screen has got cluttered. Just a second. Okay, are you able to see it now? Yeah, yeah. Sorry. Okay. Yeah, the second technique, nothing but your numerosity reduction. So numerosity reduction, you have two types of techniques. One is what is called the parametric method, under which we have the regression, and the second one is what is called the non-parametric method, where you have techniques like histogram analysis, clustering, sampling, and other things. Okay, so to tell you about regression, so previously I had shown you this example. Maybe one day we can work it out by having an extra class. This is what is called a simple linear regression, where the values of height and the values of weight is given, where you try to find a correlation between the height and weight, and then given the height of a person which is not available in the data set, you will be able to predict the weight of the person. Okay, so that's all about linear regression. The same way we have what is called your multiple linear regression. So multiple linear regression, you can see here. So here a data set is being given. The MTCAR data set is given. So what is this multiple linear regression all about? Okay, so here you can see here. So it is basically giving you a comparison between the different car models in terms of these attributes. That is the mileage per gallon, the cylinder displacement, the horsepower, the weight. Okay, so what you're trying to do is you're trying to establish the relationship between the mileage per gallon with respect to your displacement, horsepower, and weight as the predictor variable. So what we're basically doing is we are creating a subset of these variables from the MTCAR data set. Okay, so that's where the data reduction comes into picture. So we are trying to tell multiple linear regression as a data reduction technique. Okay, so if you open this MTCAR data set, MTCAR data set, if you try to open, it will be having some 20 to 25 attributes. From those 20 to 25 attributes, we are taking these attributes, that is MPG, the mileage per gallon, and the relation between MPG and displacement, horsepower, and weight. Okay, we are trying to establish that. Okay, so wherein we are creating a subset of the data of these variables for analysis purpose. Okay, so that's what your multiple regression is all about. Okay, then the third one is what is called your log linear model. Okay, so what about this log linear model? Log linear model. Okay, so these type of models, it is used like when you have variables which will have a, you can say, an exponential growth, exponential growth sort of a relationship. Okay, so for example, let me say you put some amount or money into your savings bank account. Okay, so you expect to see the effect of what is called a compounding interest with an exponential growth of your money. Okay, so I mean, for these type of scenarios, you go for what is called your log linear models. Okay, so these type of scenario, they are not linear in relationship. Okay, so in these sort of cases, the log transformation will generate whatever desired linearity is required. Okay, that is the thing. Then you have what is called the non-parametric models. You have the histogram analysis, clustering, and sampling. Okay, so histogram analysis, you can see here we had already discussed about histogram, what histogram says and how the histogram shows you the outlier data and other things. Okay, so like what basically the histogram does is it will partition the data distribution into some subsets, you can say disjoint subsets, or into some buckets or bins. Okay, so if those buckets or bins are having only one attribute, then we call it as a singleton bucket. Okay, so otherwise, using the histogram you can even represent continuous ranges of variables. Okay, so that is what you're having able to represent the data with a reduced representation. That's what is numerosity analysis all about. So numerosity analysis tells about choosing an alternative smaller forms of data representation. Okay, that's what is numerosity analysis all about. Okay, so here we are telling about numerosity analysis using the histogram. Okay, so in the form of a bucket. Okay, so you can represent the data using singleton buckets, or you can further reduce the data. Like you can have, for each bucket can have a continuous range for a particular attribute. So a reduced representation of the data. So this is another technique. Okay, the next one is clustering. Clustering, I'm not going to discuss what is clustering and all those things. We'll discuss in the fifth unit. Fifth unit is all about, fourth unit. Fourth unit is all about clustering, different types of clustering techniques, algorithms, and other things. So as of now, you know that clustering is all about grouping the similar components. Okay, so out here we are discussing clustering as a data reduction technique. Okay, so the cluster representations of the data. Okay, so they are actually used to represent the actual data, or they are used to replace the actual data. So the actual data is being, which is huge in size, that is being replaced by the cluster representation of the data. Okay, and again the effectiveness of it, which depends upon the data type, whatever you're using. Okay, so based on that. Okay, so that's what is clustering all about. Okay, so the next one is your sampling. Okay, heard about sampling technique? Sampling, obtaining a small sample to represent the entire data set. Okay, so choosing a representative sample. Okay, so choosing a representative subset of a population. Okay, so you have different types of sampling techniques. You have what is called your simple random sampling, then sampling. Simple random sampling means each and every item will have an equal probability of getting selected. The second one is what is called sampling without replacement. Without replacement. So, from the list which is under consideration, once a particular object is being selected, so that will be removed from the population, and then you go ahead with the further sampling. Then the third one is sampling with replacement. That is, even though the item is being selected, that is not being removed from the population, it is again considered for sampling. So that is what is called sampling with replacement. Of course, then we have one more type of sampling called stratified sampling. Okay, stratified sampling, I'll give you an example for it. So these are the different types of sampling you can see here. So yeah, this is what is called the cluster sampling. So these are being put into one cluster. City 5, this is one cluster, this is second cluster. Okay, so this is what is clustered sampling. And then here this is what is stratified sampling. So stratified sampling, I can show you what you're dividing the entire population into what is called stratas. Stratas or subsets. Okay, so let's say if it is a population, so that will be divided into, say, homogeneous subpopulation. Or you can say stratas. Okay, so which is like it should be collectively exhaustive, in the sense every element in the population, it should be assigned to only one of the stratas. These are the stratas you can see here. These are the stratas, and there should not be any overlap. There should not be any overlap among these stratas. Okay, so the population, they can be divided into stratas depending upon their maybe the languages what they speak, or the income, and let's say this is the income category. So this can be the rich, the category, the stratum which represents rich. This can be the stratum which represents the middle class, and this can be the stratum which represents the BPL, the below the poverty line. So we have three stratas. So from all the three stratas, we are drawing one sample each, and then having a representative sample, sampling. So this is what your stratified random sampling is all about. See, there is a sample from this stratum, the rich stratum, another sample from the middle class stratum, and another one from the BPL, below the poverty line stratum. Okay, so based on different aspects, you can do the sampling. So the next one is data cube aggregation. Do you remember learning about data cube anywhere? What is data cube all about? What is data cube all about? Can someone tell me what data cube is all about? Something new which you're hearing today? Anirudh, what is data cube all about?
So, data cube.
Yeah, yes, data cube.
It's as per seeing the diagram, it looks like a three-dimensional range.
Yeah. What is it used for in our data mining and data warehousing? Can somebody tell me what this data cube is used for? We are finishing our first unit today. That means the end of Ramayana is almost, done. Still, if I ask you how Rama is related to Sita, you people don't know. That's the effect right now. Can somebody else tell me what this data cube is all about?
Ma'am, it helps in multi-dimensional modeling.
Very good. Yes. Okay, so I said the real world data is multi-dimensional. It can be viewed in multiple dimensions. So this data cube is something which will enable us to model and view the data in multiple dimensions.
Ma'am,
Okay,
I have a small doubt there.
Yeah.
Multi-dimensional, but it's only three-dimensional, right? By multi-dimensional, what do you?
You can have, and see, this is two-dimensional. This is three-dimensional.
You can have n-dimensional data.
You can have 4, 5, 6, but then when we have what is called the curse of dimensionality. Do you remember discussing about the curse of dimensionality in one particular class?
Yes,
Yeah, that is when you have dimensions more than 100, greater than or equal to 100, then we may not be able to see it with our human naked eyes. So in which case we will have to go for what is called feature selection, feature extraction, feature elimination, then consider only those attributes, whatever is relevant for analysis, and then do the data analysis. Okay, so we can, if we have a 5-dimensional cube or a 6, more than that, it will be difficult for us to analyze. Okay, so one class we have discussed about the curse of dimensionality. Okay, so in short,
if you can have, if you can have n-dimensional data cubes, then where does this dimensionality reduction actually come into picture? That's my doubt.
Yeah, that's what I'm telling. If we have a huge data set, just now we were talking about this MTCAR data set. MTCAR, I'll just show you the site where you can see all those data sets. Okay, those data sets will be having 40 to 50 attributes. Okay, so if you try to represent all those things using a data cube, data analysis will become a difficult task. It is very, very difficult to do the data analysis. So you select only those attributes, whatever is relevant for you. Just now I gave you an example. For example, when you want to find out who's going to buy a particular brand of mobile, okay, so there will be n number of attributes associated with the customer database. So attributes like your telephone number or the college marks of that particular person may not be relevant. So you can remove those things. That's where the dimensionality reduction comes into picture. Removing the insignificant attributes. Insignificant attributes can be removed and then consider only those attributes, whatever is relevant for analysis. So that's where your dimensionality reduction comes into picture. We were discussing about the different techniques. Okay, so select only those attributes, whatever is relevant for analysis. I hope I've answered your question. Is it clear now?
Yes, ma'am.
Okay, right. So I'll just show you. Let me see whether I'm having that particular site where you can see the multiple data. Just a second. I think I don't have it here. I'll get you in the next. Here. It's there. Data sets. You can see here. So you just visit this site. And let's see where is our empty car data set. Empty cars. Yeah. So I'm downloading this empty car data set. I'm not sure how many. Yeah, you can see here how many. This is not having. This is not a high dimensional data. It's having only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 attributes. So out of the 11 attributes, when we did the data reduction technique by multiple linear regression, how many did we take? We took only. See, we did a comparison between the mileage. What is the relation between mileage per gallon and all these aspects? Okay, that is cylinder displacement, horsepower, and car weight. Only those things. Okay, so we have selected the data. We have selected only these features for our analysis using multiple linear regression. Same way, you can just look into the site, see, look out for data sets with multiple dimensions. And maybe in one of the classes we can do one such analysis. Since we don't have a lab attached to the subject, I cannot show it every now and then. Okay, you can make a note of this site. I'll just put it in the chat window. Okay, right. So let's come back. Okay, so this data cube, what I was telling, so it represents the aggregate data. You can see here the quarter data is being represented, quarterly data. Quarterly data in the sense 4 months, a quarter. First quarter, the entire time period is divided into 4 quarters. Okay, so same way you can provide the data in multiple multiple levels of aggregation. Okay, so instead of quarterly data, you can provide monthly data or daily data or weekly data. So different levels of granularity can be provided for the different dimensions. Even the region, you can see here the country. So this is country-wide aggregation. So at the next level, you can provide state level for a particular country, state level or district level or region level. Okay, so these are the different levels. Okay, so this is a 2-dimensional view of the sales data. Okay, so 2 dimensions. Then the next is 3 dimensions. So what is the analysis that we are going to do? So that matters. This is a 3D dimensional 3D data cube. Okay, so 3D data cube. Yeah, you can find out what are the items which is being sold per quarter in one particular city, let's say Vancouver. Okay, so by looking at this, you can easily make out. Okay, so just like you do your you write relational queries for querying your relational databases using your structured query language. So on data cube, you can perform a lot of operations. You have operations like slicing the data, dicing the data, rolling up of data, or drilling down of data. Okay, so all those operations can be performed on this data cube. So that's how you do the data analysis, by selecting the attributes. Okay, so that's regarding the data cube aggregation. Okay, so the next one is data compression. So data compression, so it can either be a lossy compression, where you can see here, this is the original data, the compressed data. So yeah, an original data is being approximated here, lossy compression, whereas lossless compression will give you back the original data as such. Okay, so this can be applied for string compression, audio video compression, time sequence. Okay, so all these aspects. So next, moving on to the last step, nothing but your data transformation. Okay, so data transformation. So what is data transformation all about? Transforming the data or consolidating it into some process, into some form. Okay, so that your data mining process becomes little more efficient. Okay, so whatever patterns you have found, so that becomes more understandable manner. Okay, so like all these methods, whatever you see here, so many of these methods we have already discussed. So do you remember discussing about smoothing technique, data smoothing technique? Yes or no? Data smoothing technique, how to remove the noise from the data. Am I speaking to a dumb computer? Or everybody are sleeping in the class? What is happening? This is not the 5th hour to have a heavy lunch and sleep. This is before lunch. Are you all sleeping? Vishal, what are the various data smoothing techniques? So Vishal has just connected and gone for the day. So no attendance for Vishal today. Vishal Basham, no attendance. Shreya?
Yes,
Am
ma'am.
I audible? Shreya, what is it? Please answer my question. What are the various data smoothing techniques that we have discussed? What are the various data smoothing techniques that we have discussed? Nobody have the habit of writing down certain things, sir? Headings. Nobody remembers anything. Okay. So how are you planning to write your exam day after tomorrow? See, the noisy data. How do you handle the noisy data? By binning, regression, clustering, combined human and computer inspection. All these we had discussed, right? The data cleaning process, the data cleaning process, the data smoothing process. All these things we had discussed. So, I mean, go through all those. Okay, reduction of noise. Then, of course, we will discuss this part, the normalization part. Okay, something which we had not discussed when we discussed the smoothing techniques. Okay, or the aggregation. Okay, so now coming to normalization. What is normalization all about? Normalization. You're trying to transform the data in such a way that it's going to fall in some range. The range could be between 0 and 1, or it could be from -1 to 1. Okay, so you're trying to fit the data into some range. Okay, so the terminology standardization, normalization, so these are all being used interchangeably in as far as data pre-processing is concerned. Okay, so through the process of normalization, you are trying to give equal weightage to all the attributes, which is whatever is under consideration. Okay, so you have different types of normalization technique. Okay, so you can see here the min-max normalization technique, some formula is being given for it. Then you have what is called your z-score normalization. Then you have what is called your normalization by decimal scaling. Okay, so all these techniques in data mining or machine learning, so especially this normalization, that's useful when you're going for some classification algorithms using some neural networks. Okay, so wherein you have this distance based measures. Okay, so you have this nearest neighbor classification and clustering, so there the normalization plays a big role. Okay, or if you're using neural networks, okay, so you can even normalize your input values of each of the attributes, so that will speed it up the learning phase. So that's where the application of normalization comes into picture. Okay, so then these are the different techniques which are being used for normalization. The first one is what is called your min-max normalization. Okay, so this basically will perform a linear transformation on the data. You can see the formula being put here. You can look at the formula, and an example is also being given there. So a linear transformation of the original data is being done using the min-max normalization. Okay, so an example is being given. Okay, what it says is, suppose the income is being given. The minimum and the maximum values of the income is being given. So one is given as $12,000, and the second one, the maximum, is given as $98,000. Okay, so you want to map the income between the values, or you want to normalize it between the values 0 and 1. Okay, so in which case you can go for what is called your min-max normalization. Okay, so this particular value, that is $73,000, a value of $73,000 for income, so that gets transformed to the value called 0.716. Okay, so this is what is min-max normalization. Okay, so but then This is an ordinary case, but then in case there are outliers, okay, outliers or noise or some values that is going to dominate this min-max normalization, then you go for what is called your z-score normalization. So next you have here, the formula is given here, so you can work it out. So the z-score normalization, wherein you're given the mean and the standard deviation. So this is a normalization which is being based on your average value and the standard deviation. Okay, so this I mean, like when you have the actual minimum and the maximum of the attribute is not known. Okay, so then you can go for the z-score normalization, or the case where I just mentioned there are outliers that is going to dominate the min-max normalization. So in such case, you can go for what is called your z-score normalization. Okay, the last one is what is called normalization by decimal scaling. Okay, decimal scaling, the last one. Okay, so this actually what you're doing is you're moving the decimal point of the values of the attribute. Okay, decimal points are being moved. So how much it is being moved depends upon your mean, absolute deviation and other things. Okay, so the formula for it is being given. So the objective of your normalization is to transform the data so that it falls between a range. Either it could be from -1 to +1 or between 0 to 1, and give equal weightage, the same weightage for all the attributes. So that's what is normalization all about. Okay, so next is the last topic is what is called a discretization. So discretization, the types of attributes and other things are being discussed. I think all these data discretization techniques are the same as your techniques, whatever we have discussed so far, as a part of your data cleaning or integration. Your binning. Binning, do you remember? Binning. At least one person tell me in the class, otherwise I'll really feel bad. Did we discuss binning in the class? I will not ask you what it is. At least tell me whether we have done it in the class or not. Yes, ma'am. Okay. So binning by means of calculating your bin mean or boundaries, median, all those things we had seen. Binning, histogram analysis, again the same clustering, decision tree, correlation. Correlation also we had seen different types. One is chi-square test. Another one is computing the Pearson's correlation coefficient and trying to understand the relationship. All this was discussed. So those again come under the category of what is called a data discretization techniques. Okay, so I'm not going to discuss. See the same. I think this example, the same example was discussed when we discussed the data cleaning, binning for data smoothing and cleaning. Okay, then finally the last topic that is being left is what is called a concept hierarchy generation. Concept hierarchy. Okay, so I had given an example for this, but then I never mentioned the name for it actually. Okay, so concept hierarchy means you are trying to transform the data into multiple levels of granularity. Okay, so what I mean to say is, for example, if it is a time attribute, okay, so I'm trying to transform a particular attribute or a data into multiple levels of granularity. For example, if it is time, okay, so time I can view it. If it is the sales data, I can view it on an yearly basis. Okay, at the next level, I can view it on a quarterly basis. That is 4 months data aggregation can be obtained. Then at the next level, I can see it on a monthly basis. These are the different levels of granularity which helps in data transformation. Okay, a yearly data, then quarterly data, a monthly data, a weekly data, daily data, or hourly data. These are the different levels of granularity. Okay, so when you have such data mining patterns regarding the sales, okay, so you can find it with with related to different countries or different regions or individual branch location. So you can have it, view it at different levels of granularity. Okay, so a user or a data mining expert can easily define a concept hierarchy. That's what is called the concept hierarchy, by specifying either it can be a total ordering of everything, all that of the attributes. What has happened? Okay, yeah, by specifying a total ordering of the attributes, or it can be a partial ordering of the attributes at the schema level. Schema, at the schema level. Okay, so concept hierarchies facilitate drilling down of the data or rolling up of the data in the data warehouse to view the data in multiple levels of granularity. Okay, so yeah, the lower level concepts, it can be numeric values for age. Okay, at the most lowest level, okay, numeric value for the age, or at the higher level, it can be the age of the people. It can be split into different hierarchies, concept hierarchies like youth, adult, senior. So youth means you can say the age group from this to this. Adult means the age group from this to this. Senior means 60 plus. Okay, 60 to 100, that way. Okay, so concept hierarchies can be specified. Okay, concept hierarchies can be explicitly being specified by the domain expert. Okay, so so these are the, that's what is concept hierarchy generation all about. Okay, so you can see, okay, partial ordering or total ordering, from street to city to state to country. Okay, so or, okay, grouping, all these belong to the state of Illinois. Your Chicago and Urbana and Champaign, belonging to Illinois. Or you can take only, okay. Or you can go for automatic generation of hierarchies, or automatic levels by analysis of the number of distinct values. Okay, so that's what you can see, the one which is having the most high, distinct value, that can be at the lowest level of the hierarchy. The street is at the lowest level of hierarchy with these many distinct values. At the next level, you can roll up the data and you can analyze it based on the city information. Okay, a lesser number of values, or a province or a city, state level, still lesser values. Or at the highest level of the hierarchy, we are having what is called a country, where we have that is a little more generalized data with only 15 distinct values. Okay, so yeah, some hierarchies can be generated automatically on the analysis of the number of distinct values per attribute. Okay, so the attribute with the most distinct value will be placed at the lowest level of the hierarchy. You can see here. So this is the one, because you have more number of streets, maximum number of streets, then lesser number of cities, lesser number of states, lesser number of country. So you have the least number of countries here. So that's why it is kept at the topmost of the hierarchy. Okay, so this is another method for transforming the data transformation. Okay, right. So with that, we come to the end of this particular unit. Okay, so I know many of these techniques, only when you do it, implement and see it on a see it practically, you get better understanding. You do understand it in a better manner. Okay, so maybe we can take up a small case study and perform a data pre-processing on it, wherein I can show you how the data is being cleaned, integrated, reduced, and transformed. Okay, so that will give you a practical understanding. We'll take it up after your CT. We'll do it in Python. We'll do all these aspects in Python and I can demonstrate this. Okay, if you have any doubts, you can ask me. Otherwise, I'll take the attendance and we'll have a small revision of whatever we have done so far. Are you listening?
Yes.
Okay. I had to rush up. It's a fact I had to rush up today. That's there. But still. Okay, answer your attendance. Anirudh?
Present, ma'am.
Dharani?
Present, ma'am.
Ramharini?
Present, ma'am.
Kalyan Sundar?
Present, ma'am.
Aravind?
From chat box.
Put in the chat box. Okay, Aravind, fine. Sharan Varghese?
Present, ma'am.
Shakti Priya?
Present, ma'am.
And Ashok?
Present, ma'am.
Shreya?
Present, ma'am.
Likita?
Present, ma'am.
Suveda?
Present, ma'am.
Vishal Bhashyam,
Present, ma'am.
Srimati, M. Srimati,
Present, ma'am.
Kamini Nityashri,
Yes, ma'am.
Pranav Ram. Pranav is absent. Is Pranav absent? Okay, marking him as absent, 41. Srimati S.
Present, ma'am.
Raja Singh,
Present, ma'am.
Pooja,
Yes, ma'am.
Pranav is absent, Srimati present, Raja Singh also present, Pooja present, Lavanya,
Present, ma'am.
Nityashri,
Present, ma'am.
Shriram.
Chat box.
Okay. Shriram is present. Then Satyamohan,
Present, ma'am.
Sharan, Sharan is present or up? Okay, no response. Fine. Sharan is marked as absent. Aviral Patel, no response, absent. Hemavartini,
Present, ma'am.
Ajay,
Ajay, present, ma'am.
Excuse me, ma'am.
No
Aviral
problem.
present. Actually, I have
Akshakal
been
Saha.
interconnected. Okay.
Okay.
Okay, the present,
What
ma'am.
about Karthik Balaji,
Present, ma'am.
Santosh Kumar, Anand Arun, Anand Arun. Okay, noted. Rahul P.
Present,
Suhasini
ma'am.
Srikanth, Apurva
Present, ma'am.
Ravichandran,
Present.
Mithun,
Present, ma'am.
Adityan,
Present,
Selva Niklesh,
Present, ma'am.
Ramcharan,
Present, ma'am.
Chintamurari,
Present, ma'am.
Santosh Kumar,
Present, ma'am.
Santosh Kumar is present. Pavitra Shri,
Present, ma'am.
Praveen,
Present, ma'am.
Rakesh.
Present, ma'am.
And coming to C section, Nityashri,
Present, ma'am.
Nisho Kadriven,
Present, ma'am.
Abel Prashant, Abel,
Present, ma'am.
okay. Preetika,
Present, ma'am.
Kevin Kurian Joseph,
Present, ma'am.
Hiten,
Present, ma'am.
Adya,
Present, ma'am.
Jayvora. Jayvora is absent. Kishore,
Present, ma'am.
I wasn't able to unmute.
okay, Jayvora is present. Okay. Kishore is also present. Okay,
Yes, ma'am.
Sridevi,
Present, ma'am.
Yash Rai,
Yes, ma'am.
Jayesh Kumar.
Present, ma'am.
Okay, C section, everybody are present. What about A section? Many absentees. Anybody who has missed the attendance can give me now.
Ma'am, Sharon gave it in chat box.
Sharon is 63. Let me mark him.
Ma'am, Aviral 67.
Just a second, just a second. Sharon, let me mark him. Sharon is marked present. Then who else?
Aviral 67 has an internet issue.
Aviral Patel. Okay, Aviral Patel.
Ma'am,
also
yeah.
Yeah, fine. I've given you attendance. Anybody else? That's it, right? Okay. So now we have come to the end of the first unit. A small revision before your CT. You have any doubts, you can ask me. Any doubts? No doubts means it tells me two things. What are the two things, Anirudh? No doubt means either everybody has understood everything or nobody was listening and nobody didn't understand anything. Let me go for the first one, that you people were listening and you were understanding things. Was it interesting or too very boring? No response from anyone. Okay. So, of course, I do understand that to understand data analysis, we should do some practical data analysis or hands-on. Only then you will have a complete understanding of what basically happens. Unfortunately, this is a elective paper. We don't have a lab associated.
Sorry for interruption.
Yeah.
While selecting the electives last semester, I don't know about others. I never knew that it's a T code paper. I never knew that. I thought it would be a J code.
I couldn't hear you, Anirudh. What is it?
No, ma'am. Regarding this paper, I thought that the electives would be a practical. I mean, it would be a J code. Is what I thought. But we didn't know it was a T. I didn't know it was a T code last semester.
Yeah. Unfortunately, data mining is a T code paper. So that's the reason why, because all these things, I know, like when I say it, I mean, theoretically, there is a limit to which you can understand certain things. We need
Yes,
to
ma'am.
practically
Like
see it.
if we can use the SQL server in a certain way,
Yes.
do some programming in Python.
Yes, definitely. Actually, this data pre-processing entire thing can be done practically using Python, Google Colab, or whatever you say, Python interface you have. You can do it wonderfully. You can visualize the histograms and analyze the outliers. Everything can be beautifully done. The dimensionality reduction, all these things can be done, including your principal component analysis. Everything can be done. Your linear regression. So we'll just try to do it on one of the days. Maybe I'll take an extra class, or I'll give you an assignment, make you do, and then discuss that in the class. So that will give you a better grasp, because if I start taking another class of yours to do a practical thing, we will lose the class, because for cycle test, we are losing 2 classes, plus I need to start with the second unit. So that also we have a huge portion to be covered. Okay, so we have our limitations. Okay, so I'll give you an assignment. I'll give you a practical assignment. You do that, and then we'll discuss that in the class. Okay, I hope all of you are
And
familiar
one
with.
more thing, ma'am, regarding the crossword puzzle that you've uploaded in GCR.
Okay.
There is no space to attach the work. Is it an assignment?
No, that is not an assignment. It was just that whatever work that we had discussed that in the class, right? The crossword was discussed in the class, and I think many of you have already worked out and got the answer. So I just put it as a reference. It was not meant as an assignment or anything. Assignment I'll give you. I was waiting for this data pre-processing to be over to give you an assignment. So let the cycle test be over. You concentrate on that. After that, I'll give you an assignment. Okay. Right. So now let's have a small revision kind of a thing. So we had basically 3 chapters. 3 chapters in the first unit. The first chapter was all about what is basically data mining, then what kind of data can be mined, or what kind of patterns can be mined, what is the technology which is being used, what are the kind of applications targeted, and what were the major issues in data mining. That was what we concentrated in the first chapter. Okay, so then in the second chapter, first I'm giving you a brief of what we have covered so far. So does anyone remember what we discussed in the second chapter? Second chapter. Second chapter.
It was about various types of data.
Yes, very good. Because before we start doing data analysis, we should have an understanding of we need to get to know our data. What is our data? What are the different types of data? What are the different types of attributes? Then we also discussed about the basic statistical descriptions of the data. So by learning about what is the measure of central tendency, like mean, median, mode, then what is the significance of measures of dispersion, like your range, interquartile range, or quantiles, and all those things, the measures of dispersion. Then we discussed about the various data visualization techniques, how to graphically plot them. So that is what was our second chapter all about, getting to know about your data. Then finally, the third chapter, what was the third chapter all about? Just what we have finished. So that was all about data pre-processing. Because in the knowledge discovery process, so we had discussed about the knowledge discovery process in the first chapter. So in that data pre-processing, wherein we had to discuss about data cleaning, integration, reduction, and transformation. Okay, so that's how our first unit was split. Okay, so I think it's time up also. So we don't have a time for detailed revision or anything. Okay, so anybody, if you have any doubts regarding any of the topics, you can text me in the group. I'll be answering your queries. So the recording will be stored in Arvind's Drive 17. Please